Math 1332, Chapter 7, Consumer Mathematics, Section 1, Percents, Video 5, Two Approaches for Basic Percent Problems, Part 2. Setup number 2, a proportion. In the previous video, we introduced setup number 1. Setup number 1 was a simple equation. We took a basic equation, a basic percent problem of the form A% of B is C, and we translated it to an equation by translating the word of to times and the word is to equals. And in the problem, we're given two values and we bring them into the equation with the caveat that if we were given the percent, we change it to a decimal. And then we represented the missing value with an x. We then solved for x. If x represented a percent, we converted the decimal back to a percent. But setup number 2 is a proportion. And this may be one that you're familiar with. Before we get started, just a real quick reminder that a proportion is just an equation, specifically stating that two ratios or fractions are equal to each other. So a proportion is a fraction equals another fraction. No more, no less. For a basic percent problem of the form A% of B is C, so in other words, the same type of basic setup that we had before, we're going to set up the following proportion. And I'm going to show you two ways to think about it. One way, let me put it on draw, there we go. One way is to, actually there's only one way I'm going to think about it. We're going to take the percent number and we're going to put it over 100 because that's what a percent literally means. So if it were 60%, I would put 60 over 100. And then we're going to put the is number on top of the of number. If I were to set it up using the A, the B, and the C in the problem, it would be A over 100 equals C over B. But I don't want you to get hung up on calling something A, B, and C because it's more about the position of the numbers and not what letter I choose to represent it. One quick comment. If the percent is given, we do not change it to a decimal. And the reason we don't change it to a decimal is when you do change it to a decimal, you are accounting for the per 100 part of percent. So for example, 60% means 60 per 100, or 60 over 100, or 60 divided by 100, which moves the decimal 2 places to the left. But if I put that number over 100 and also move the decimal, then I'm double counting for that 100. So by putting the percent over 100, we're already accounting for the per 100 aspect of being a percent, and so there's no need to take any other action like move the decimals. In the videos that are, in the examples that are about to follow, much better. In the examples that are about to follow in the next page, it's all going to be about using this proportion. And remember, we're going to know 2 of the 3 numbers. The one that we don't know is going to be the x. Then we'll cross multiply and solve. And in case you forgot what cross multiplying looks like, you're about to be reminded. Examples using proportions. We have all 3 variations of basic percent problems here. We're missing the is number in the first one. What is 42% of 90? We're missing the of number in the second one. 30% of what is 51? And we're missing the percent in the last one. 55 is what percent of 121? I did rearrange the order of the sentences. If you'll notice in the first and third ones, the is precedes the of, but in the second one, the of precedes the is. You're going to run across that because is as a verb allows for a little bit of flexibility in who's the subject of the sentence and who's the object of the sentence. But all of these are going to run the same setup. And just to remind you what that setup is, the setup will be whatever percent number we have goes on top of 100, and we put that equal to the is number on top of the of number. So we're going to focus on locating these numbers, putting them in the correct place. Let's start with the first one. What is 42% of 90? Where is this 42 going to go? Well, it's clearly a percent, and so it's going to go on top of a 100. And remember, when you use proportions, you do not move the decimal. 42% means 42 per 100. We've already accounted for the percent nature of that. And then in the other fraction, we're going to put the is number on top of the of number. Which number is the 90? Is that the is number or the of number? Well, it's the prepositional object of the preposition of, so it's the of number, and it goes on the bottom of the fraction. The number that we're missing is the is number. Now, I know there's a number after the word is, but in this problem, that number is already spoken for. It's a percent. Because that's the number that's missing, that's where the x is going to go, and it goes on top of this fraction. Percent over 100 equals is over of. Once you've got the proportions set up, you basically have an equation. The most common technique for solving this is called cross-multiplying. Some of you already know how this goes. But cross-multiplying is where you multiply diagonal and write the results. So 100 times x is 100x equals, and then you multiply across the other diagonal. 42 times 90 is something. I don't feel like thinking about it in my head right now. It's 3,780. But I am going to go ahead and write 42 times 90 to emphasize that we're doing two multiplication problems equal to each other. This technique is also called the butterfly method because when you circle the cross products, kind of looks like a butterfly. But once we've done that, we've eliminated the fractions, and now we just have to isolate the x. First, we have to multiply the 42 and the 90. That is 3,780. Then, just like in the simple equation setup, to isolate the x, you just have to divide by the number in front. So if we divide by 100, we get x equals 37.8. So what is 42% of 90? 37.8 is 42% of 90. Let's take a look at the next one. 30% of what is 51? Let's identify the numbers that we're given. We are given this number, which is clearly a percent. So that will go on top of the 100. Say 30 over 100 is equal to, and what other number are we given? We're given 51, but is that the of number or the is number? Well, it doesn't follow the word of, so it's not the of number. It's got to be the is number. And the is number goes on top of the of, on top of the fraction. What we're missing is the of number. Of what? Oh, no, you didn't tell me. So that's going to go on the bottom. And if you notice, the x is in a different location, but it doesn't change what happens next. This is still a cross-multiplying setup. We get 30 times x. And for the sake of space, let's go ahead and multiply the other diagonal product. 100 times 51 is 5,100. And then to solve that, we would divide both sides by 30, which would cancel the 30s, and I forgot to cancel the hundreds up there. Well, they did cancel, I just didn't physically cross them out. And then 5,100 divided by 30 is exactly 170. You can check it if you don't believe me. Pretty sure it's right. So the setup was a little bit different because of the location of the x, but the follow-up was the exact same, cross multiply and then solve. And it won't surprise you that it's going to be the same story for this third and final example. 55 is what percent of 121? Well, let's see what we're given. We're given the is number. And again, the is number can come before or after, depending upon the order of the sentence. But the one that's unmistakable is the of number. It will always follow the word of. The percent is also unmistakable. It will have a percent. So if you see a number and you're not sure which one it is, it's probably the is number. All right, let's set this up. We're missing the percent, and so that's what number is going to get represented by the x in our proportion, and that goes on top of 100. The is number is 55. It goes on top of the second fraction. The of number is 121. And again, the x is in a different location, but the approach is still the same. We're going to cross multiply. That will give us 121x. This one will give us 5,500. 121x equals 5,500. and then I just have to divide. This will not divide evenly, but I did that on purpose. 45.45 repeating. And a quick comment about this answer, and I can't remember if I said it previously. Yes, if the percent is given, we do not change it to a decimal, but I didn't say the following. If you're given a percent like the first two problems, I'm going to highlight them in pink. If you're given the percent in the first two problems, you do not change them to decimals because you're already doing that in a sense by putting it over 100. But if you're missing the percent, don't move the decimal at the end. Why? Because you never turned it to a decimal in the first place, so you don't have to change it back from a decimal at the end. It already represents your percent because it was the number over 100. So it was the number per 100. It is your correct answer. Now the homework, if you get an answer like 45.45 repeating, we'll probably ask you. So just to wrap up this video, let's say that the answer was 45.45 as a percent, and they asked you to round this to 2 decimal places. Excuse me, the 45 is repeating as a decimal. To see what it rounds to, I would recommend writing out a few of the 45s. Maybe just a couple would be okay. And if they wanted you to round to 2 decimal places, then you would have to look in the third decimal, and based on that number size, either move the previous decimal up a notch or leave it alone. The rule for rounding is simple. If you want to round to a certain decimal place, like the second decimal, look in the third decimal and look at that digit. If that digit is 4 or less, then just chop it off at 2 decimal places. Otherwise, you would round up the second decimal to the next digit. So if I were to round this, it would be 45.45%. Now, had I rounded it to 3 decimal places, it would have been a different story. Because had I rounded it to 3 decimal places, then I would be looking, I would be looking here, and I would be looking at the 4th decimal place to make the decision on whether or not to round. Since that is 5 or greater, then that means the digit prior would go up by 1. So had it said 3 decimal places, it would have been 45.455%. So be very careful when you're rounding. It's an easy thing to do, but it's also an easy thing to overlook and be careless with if you're not careful.